decided for tonight was to do a lesson on bivariate data. So this would be part of your paper 2. When you are doing statistics in paper 2, your question is going to be split between grade 11 work and grade 12 work. The grade 11 work will cover things like mean, standard deviation, cumulative frequency, O-drive, that sort of stuff. And the matric stuff is this particular bivariate data. And really what we should be aiming for is the 20, 25 marks that this section is on. We should really be aiming to get 25 out of 25 for that. Okay, so yeah, I just wanted to run through that with you again and just go through a couple of things. I know there were some kids at my school. This was one of the questions that I mark now in trials, and I was surprised at how many boys were unable to do this, even though it's something that we have done in class. Okay, so the question starts off: a farm stall sells milk in 5-litre containers to the local community. The price varies according to the availability of milk at the farm stall. The price of milk in rands per 5-litre container and the number of 5-litre containers of milk sold are recorded below. Okay, so you can see here they've labeled the rows for you. The top row is X. Okay, so price of milk in rands per 5-litre container. And the bottom row is Y. Okay, so the number of 5-litre containers sold. The first thing that they ask us to do is on the grid provided, they want us to draw a scatter plot. So I have gone and chopped that out so that it's here. And let me see if I can make it a little bit smaller. Is it okay if I make it a little bit smaller? Can everybody still see that? Is that okay? And now what I want to do is I want to plot my data. All right, so the reason that we call it bivariate, the word bivariate means 2 variables. So in other words, what we've got here is we've got an X variable, which is the price of milk in rands per 5-litre, and a Y variable, which is the number of 5-litre milk containers that have been sold. Okay, so what I'm going to do is I'm going to plot each of these like a pair of coordinates. So X is like the X coordinate and Y is the Y coordinate. So 26 and 48. 26 is this line over here. So 48 would be, that would be 46, 47, that would be that point over there. Okay, and then 32 and 30 is going to be over here. 32 and 30, that point there. 36 and 26, it's this point over here. 28 and 44. That point there. 40 and 23. Be that one over there. 33 and 32. 33 is going to be 31, 32, 33, and 32. It's going to be there. 29 and 39. It's going to be over there. 34 and 24. Oopsie, too far up. One over there, almost there. Last one, 20, well, second to last one, 27 and 42. So that's there. And then 30 and 33. So 30 and 33 is going to be over there. Okay. So 3 marks for plotting the points correctly. Just like that. So it's literally just a case of plotting them as X and Y coordinates on the Cartesian plane. So everybody should be able to do that. Now they want us, yes, so P-Ware, what's your question? You're welcome to unmute a P-Ware and ask your question.
No, I do not have a question.
Okay, so it's just you got your hand raised, so maybe it was an accident.
Yeah.
Okay, all right, never mind, that's fine. Okay, so the second thing that they want us to do is they want us to determine the equation of the least squares regression line. Okay, so that's the second question here. Determine the equation of the least squares regression line for the data, right? So in order to be able to do that, we need to use our calculators. Has everybody got their calculator with them today? Has everybody got a calculator? That's it, Maya, quite right. Okay, so just going through it for the people that are not 100% sure, but is y equals a plus bx. So I'm going to write the formula on the screen for you. I'll just do that quickly. So there we go. So where a represents what would be the y-intercept and b represents the gradient of the line, okay, which we can see in this case is going to need to be negative, okay, because it's definitely a downward trend. All right, so now everybody get your calculator, turn it on, okay. What we're going to do is we're going to enter this data into the calculator. The first thing that you want to do is press the mode button. Then you want to press the button for stat. So normally it's number 2. Choose option number 2, a plus bx. And you'll see there are 2 columns, an x column and a y column. We're going to put all the x's in and we're going to press equals after each number that we've put in. Do it slowly and make sure that it's correct because you don't want to have to do it again. Once you've entered all the numbers into column A, go over to the, column X, go over to the Y column and enter the numbers from 1 to 10 over there as well. When you're finished, please just pop something into the chat and say that you're done, and then we can talk about the next step in the process. Okay. So you can just type done in the chat when you've entered all the data, and then I'll explain the next step. Cool. Okay. So now you're going to press AC, shift, and 1. AC, shift 1. And then you're going to have 6 options that come up. Okay, what you want to do is choose option number 5 where it says REG. So it says REG for regression. So you're going to choose option number 5. And there are 3 things there that you need to write down, okay, at this point in time. Only 2 of them are we going to use for the equation of the least squares regression line. But we don't want to come back later on and work out the correlation coefficient again a second time by re-entering all the data. So make sure that when you're working out the equation of the least squares regression line, that you write down the value of the correlation coefficient at the same time, okay, so that you don't have to go back and go and rewrite the data. And you can just put it anywhere that you know that you've done it for yourself. So what we're going to do is we're going to press 1 and we're going to press equals. Tell me what you get for the value of A. Round it to 2 decimal places. What are you getting? No problem, Nick. It's nice to have you with us. Yes, Imihle, Naledi, Ibrahim. Perfect. That's exactly what I'm getting. All right, so we're getting 90,48. Lovely. So we're going to round that off to 2 decimal places. What are we getting for B? So now if you want to go back and get B, you've got to go back and repeat the process again. So you've got to go AC, shift 1, 5, and then choose option 2. Okay. Amanda, me too. I'm getting the same answer. -1,77. right? And then what we want to do quickly while we're here is, well done, guys, that's perfect. Yes, 100%. We want to work out the correlation coefficient. So again, we're going to press AC, shift 1, choose option 5, and then choose option 3. Now that's R, that's your correlation coefficient. So what I'm going to do is I'm just going to write R down in a different color over here. So my correlation coefficient R is negative 0.94. Yes, that's what I'm getting to, Naledi. Okay, me too. All right, and now you are ready to start using your calculator for computing again. So you can press the mode button, press number 1, that switches it back onto computing, and then you can continue. Okay, so now, in order to get all 3 marks here, what we want to do is we want to write it in the form of the least squares regression line. So what I still need to do here in question 2.2 is write y hat equals 90,48 minus 1,77 x. Okay, so you're going to get 3 marks for this. There's going to be a mark for A, a mark for B, and a mark for writing it as an equation. Don't forget, you must not leave off the x. Okay, otherwise you're going to lose that mark for the equation. Okay, everybody good so far? Making sense, everyone? All happy? You shouldn't be, Pavalo, but you are supposed to put it on. Okay, you are supposed to put it on, but I don't think that they'll mark you down for that. All right, so question 2.3 now, let's do that. So if the farmer sells a 5-liter container of milk for 38 Rand, predict the number of 5-liter containers of milk he will sell. All right, so in other words, when they give us this 38 Rand 5-liter container of milk, has he given us an X or have they given us a Y? What do they want us to do? We do substitute into the equation, Maya, quite likely, but where does this 38 belong? Is it an X or is it a Y? What are we calculating? When they want to predict the number of 5-liter containers of milk he will sell, it means they're asking us to make a prediction about, yeah, so we sub into X and we're making a prediction about Y. Yeah, quite right, guys. Okay, so they're giving us the X and they want us to predict what the Y is going to be. Okay, so we're going to come along. We're going to say Y is equal to 90,48 minus 1,77, and then we're going to put in our 38 over here. And then again, we're going to use our calculators to then estimate the answer. Okay, what are you guys getting as an answer? Yeah, that's what I'm getting as well. Okay, so 23,22. Right, now, obviously he can't sell 23.22 containers of milk, but that doesn't matter. All right, we would just leave our answer rounded to 2 decimal places. Okay, there we go. Good stuff. Well done, everybody. Okay, so it's meant to be really easy. We're meant to be able to get all the marks here. Again, we would get a mark for substituting and a mark for our answer. Okay, all right, 2.4 now. They want us to refer to the correlation between the price of 5-liter containers of milk and the number of 5-liter containers of milk that have been sold, and comment on the accuracy of your answer to question 2.3. Right, so this is a little bit more difficult, isn't it? Because now they're actually asking us to think. They're not just asking us to substitute into an equation. They're asking us to express an opinion on the accuracy of our answer. So now our correlation coefficient has a value of negative 0.94. How does that, I mean, if somebody said to you, comment on the correlation coefficient, how would we describe this correlation coefficient? Remember, we have to use the words positive or negative, and then we have to describe its strength. So it could be weak, or it could be moderate, or it could be strong, or it could be very strong. So what words would we use here? Yes. Okay, so it is a strong. You could even use the word very strong. Negative correlation is correct. Okay, so there is a very strong negative correlation. So if R is equal to negative 0.94, that means there is a very strong negative correlation. Now, the reason that it is strong, I mean, obviously it's negative because it's got a minus in front, but remember, R is a number that has to be between -1 and 1. Okay, so if R is equal to 1, then we would call that a perfect positive correlation. If R was equal to -1, then we would call that a perfect negative correlation. Okay, so that's why negative 0.94 is very, very close to -1. That's why we would say it's a very strong negative correlation. Okay, now that's the easy part. Okay, that will get us 1 mark. To get the other mark, we now have to comment on the accuracy of our answer in 2.3. So do we think that we are going to get an accurate answer based on our correlation coefficient? Yes, 0 means no correlation, quite right. No, Yakupa, it's not if it's close to 0. Okay, so 0 means there's no correlation because 0 is exactly in the middle between -1 and 1. So if there's a correlation coefficient of 0, it means that there is no relationship between X and Y. So for example, if I decided to measure the size of your foot compared to your IQ, there's no correlation between how intelligent people are and how big their feet are. Okay, so we wouldn't be able to use that in a meaningful way because there's no relationship between the two variables. But in this situation over here, because it's very close to -1, it means that there is a very strong relationship. Yes, so it's very strong if it's close to 1 or -1, quite right. Okay, and then obviously the closer it is, if it's positive, then it's a positive correlation, which means that as the one gets bigger, the other one gets bigger. If it's a negative correlation, it means that as X gets bigger, Y gets smaller. Okay, so what we are finding here is that as the price of rands per 5-litre container increases, so the number of 5-litre containers of milk sold is decreasing. Now, that makes sense to us because, you know, people are not going to buy, 50 litres of milk in one day, are they? I mean, if you think about it, milk goes off, even if it was a family of 5 or 6 people, we would probably consume, 2 litres in a day, maybe 3 litres in a day in the absolute most. So yeah, as it becomes more expensive, people are buying less and less. Okay, so what would you like me to go through, Nick? Just explain to me what you didn't understand. Oh, sorry, I'm almost finished. We just need to comment on the accuracy of our answer. So our answer we believe is going to be. Therefore, our prediction in 2.3 is accurate. Okay, so there would be 1 mark here for the bit about negative 0.94 and the very strong negative correlation, and then the fact that we believe that our prediction was accurate. Okay, so Nick, what did you miss exactly? When you say the last questions, do you mean the last 2 questions? Yes, okay, all right, so the last 2. So just very quickly then, in question 2.3, all right, they asked us to make a prediction. They asked us to predict the number of 5-liter containers of milk he will sell if a farmer sells a 5-liter container of milk for 38 Rand. So they were asking us to use our formula from question 2.2. They've given us an X and they're asking us to calculate a corresponding Y value. So you can see that I've done that here on the screen in 2.3. I've written down my formula. I've showed that I've subbed in and I've got my answer. That's why it's 2 marks. 1 mark for subbing in, 1 mark for your answer. Okay, so that's 2.3. And then in 2.4, they were asking us to refer to the correlation coefficient and comment on the accuracy of our answer in 2.3. So what they want us to do there is they want us to provide the correlation coefficient. They want us to comment on it. So because it is negative 0.94, it's very close to being a perfect negative correlation. A perfect negative correlation has a correlation coefficient of -1. A perfect positive correlation has a correlation coefficient of 1. So it's on a scale between -1 and 1, where 0 means that there is no correlation. So in other words, there is no relationship between X and Y. Okay, so here there is a very strong relationship between X and Y. It's almost perfectly negative. It's negative 0.94. So based on the fact that our correlation coefficient is, can say that our answer, the answer that we've predicted in 2.3 is going to be accurate. Okay, Nick, I hope that helped. Right, so you can see there, matrix, it's supposed to be 10 really, really easy marks. Okay, question number 1. Yes, Cassandra, go for it. What's your question? Did you want to ask a question, Cassandra? You looked as though you put your hand up. Okay, you want to see how we draw the regression line. Okay, all right. So when you draw the regression line, let's just, yeah, I think that's a good thing to go through. All right, let me just get my pen here. All right, so how to draw the regression line. Let's just make a little heading here for you. Okay, all right. So how to draw the regression line. Okay, so if you want to draw a straight line matrix, you need 2 points. Okay, so 2 points are required to draw any straight line. Okay, so what we want to do is we want to go back to our information and we want to find 2 points that are just inside of our minimum and our maximum. So what is our smallest X value? Our smallest X value is 26, okay? So we're lucky in this case, they've also given us a 27. So we know, if we didn't know what 27 was equal to, we could use our formula to calculate it, right? So we know that when our 26 is our minimum, the next biggest one is 27. We want to go just inside what the minimum is. So we know that when X is 27, Y is equal to 42, right? So we don't have to do any calculating there. So when X is equal to 27, Y is equal to 42, that's actually a point. Now we're going to go back and look at our X. What is the maximum? The maximum value is what's the maximum X value? The biggest X is 40. Yeah, absolutely. Okay, absolutely. All right, so now we want something that's just a little bit smaller than that. So let's say we decided we're going to go with 39. Okay, we're going to take 39 because it's just inside of 40. All right, so now we don't see a 39 in our column up here. So now we're going to work out what Y is when X is 39, exactly in the same way that we calculated our answer in question 2.3. So we're going to say 90,48 minus 1,77, and we're going to pop in 39. Okay, and that's going to give us a Y value of what are you guys getting? Even me. Okay, all right, lovely, well done. Okay, so that's a Y value of 21,45. Okay, so in other words, what we've worked out here is that when X is equal to 39, Y is equal to 21,45. Okay, so now we've got 2 points matrix. We've got this point over here, which is down at our bottom end, and we've got this point over here, which is now at our top end. Okay, Cassandra, now what we want to do is we want to go and plot those on our scatter plot, right? So when X is 27, Y is 42. So when X is 27, Y is 42. Just make sure I'm in the right place here. 27, 41, 42. So that's over there. So I'm just going to make it a slightly different color. Okay, so that's the 27 and 42. And then the other one was 39 and 21.45. So 39 and 21.45, I guess, will be somewhere over there. Now you are going to get your ruler. Okay, and you are going to draw a straight line between these two. Okay, now obviously my line is just a little bit out. Hang on, I just want to try and move it. Why is it doing? Hang on a second, let me just unplug my mouse and plug it back in again. Sometimes that helps. No, okay, not helping. All right, I'll try and do it again then. Try and do it perfectly this time. There we go. Okay, that's about the best that I can do online for now. Okay, so your line, you want it to be just inside of your minimum and your maximum, Cassandra. Okay, so if they do ask you, no, just inside, no lihle. Okay, so that's why we chose a number that was one bigger than our minimum and one smaller than our maximum. You don't need the mean of X and the mean of Y. So by you using these 2 points here, Cassandra, it'll go through the mean of X and the mean of Y. Okay. So just like that's fine. And then what you can do, if they want you to as well, is that you can then use this least squares regression line to make predictions as well. All right, so I would get my ruler, and then you can read up from the x-axis to y and then make predictions about y based on that as well. And obviously they'll be a little bit lenient with you because everybody's line is going to be a little bit different. So yeah, so what you want to do is you want to find 2 points, one just bigger than the minimum, one just smaller than the maximum, and then connect those two together, and then that will allow you to interpolate, is the correct word for predicting within the data that's been given. Okay, just give me 1 second. Sorry, I'm just writing back to one of our students. Sorry, I just wanted to reply to her. Okay, so is that making sense to everybody? Are we all good to go? Thumbs up, thumbs down? How are we feeling? Good, I'm so glad. Oh, lovely, Timna. Good, Bridget. Good, my lady. Cool, Kelebochile. Lovely. Awesome, guys. Okay. Good stuff. Okay, so let's go and have a look at another question. All right, so this is, oh, my thing is still not, I wanted to try and make my thing bigger, but it's still not. Stupid mouse. Sorry, I'll see now if I can adjust the size of this picture. I don't know if it's because I don't have any power. Okay, all right. Unfortunately, can't make this any bigger at the moment. I'll see, hopefully my mouse will start playing the game again. All right, so in question number 1, it says to us, Sam recorded the amount of data in megabytes that she had used on her on the first 15 days in April. The information is shown in the table below. The first thing that they want us to do is to calculate the mean for the data set. Okay, so when they mean for you to do it this way, they don't want you to do it like you did it when you were in grade 8 and grade 9. They want you to use your calculator, right? So let's just go back through that again, how we would use our calculators in this regard. So again, got your calculator. You're going to turn it on, obviously. Press the mode button. Choose option 2 for statistics. And in this case, we want to go to the first option for variance. So it says 1 VAR. Are we all there? Oh, you've got it already. Okay. All right. So for those of us that are not that quick, well done. We're going to enter all the pieces of data. I'm just entering mine as well. We should be close to being done by now. Okay. And then again, we're going to press AC Shift 1. And this time you're going to choose option number 4 for variance. Okay, so option number 4, to get your mean, that is option number 2. So that's X bar. Okay, so you should be pressing option number 2 looks like that. I'm also getting 25 as my answer. Well done. That's perfect. All of you are managing. Cool. All right. And then the standard deviation, again, you press AC shift 1, go back to option 4 for variance, and then choose the symbol that looks like that. So the small sigma with the X. All right. So now we've worked out the standard deviation as well. So the standard deviation is 17,65. So now I want you guys in the chat to tell me, when we calculate the mean for a set of data, what does it mean? What are we actually calculating? What does it tell us about the data? There we go. I can finally make this bigger. What does the mean tell us about the data matrix? What are we actually working out when we calculate a mean? Okay, so it's the average, 100%. Okay, we're calculating the average. Good. When we calculate a standard deviation, what are we calculating then? What does that mean? What is a standard deviation? What does that mean for us? What are we doing when we're calculating the standard deviation? Does anybody know? Just hold on, I'm just replying to a learner. Just give me 1 second. No, the mean is the average, Aratile, but thank you for your answer. So what does the standard deviation mean? Isn't it funny how this is something that we've been calculating for how long, but we actually don't know what it is that they're asking us for. Just want to finish replying to Snegugu, and then I'm going to talk to you about what standard deviation actually means. Is it the variation in the data? Well, you're a little bit closer, but what it actually means, standard variation is the average distance each piece of data is from the mean. Okay, so that's what you're doing when you're calculating standard deviation. All right, it's how far, yes, how far the points are from the mean. There we go. All right, good, well done. All right, so I think it's important for us to know what it is that we're calculating and what it means for us. All right, so now they've said to us, after calculating the mean and the standard deviation, determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. Okay, so 1 standard deviation above the mean means that we need to take X bar and we need to add 1 standard deviation to it, right? So that's going to be 25 plus 17,65. Okay, so that is going to leave us with 42,65, isn't it? Okay, so the number of days on which the data used was greater than 1 standard deviation of the mean. 1 standard deviation of the mean is 42.65. All right, so now we're looking for numbers that are bigger than 42.65. So that's this one over here, that one over there only. Okay, so it's 58 and 69 only. All right, so therefore there were 2 days where her consumption of data was greater than 1 standard deviation of the mean. That's it. Okay, so that's like our upper bound, and then we're going to go and have a look at how many pieces of data lie out of that. If they said to us, determine the percentage of the number of days, what would we do with our answer? if the question was a little bit different and they asked us for a percentage? How would we calculate the percentage? Go for it, Naledi. What would we do? Just putting this on the screen. Okay, but what are you going to multiply by 100%, Ibrahim? What was your question, lady? You're welcome to pop it into the chat if you want. You can unmute if you like to.
Ma'am, can you hear me?
I can hear you just fine. How are you?
I'm good, thanks. And yourself?
I'm fine, thank you. What's your question?
You were explaining what do they mean by when they ask for the standard deviation, and I didn't get that. I think my network was bad, so do you mind repeating it for me, please?
Okay, so Naledi, they're never going to ask you what standard deviation means. They're just going to ask you to calculate and to use it. But I think it is important to understand what these things mean when we are working with them. So your standard deviation is the average distance that each data point is from the mean.
Oh, okay.
Okay, all right. So it's
Thank
the
you so
average
much,
distance each point of data is from the mean. No problem. Okay, so no, unfortunately not, Ibrahim. If they asked us to calculate the percentage of the number of days where the amount of data that was used was greater than 1 standard deviation of the mean, we have 2 days out of 15. Okay, so they told us that it was 15 days, the first 15 in April. So 2 days out of 15, and that's what you would multiply by 100. Okay, if they wanted a percentage. Okay, so in order to get a percentage, you have to multiply a fraction by 100%. Just in case it does come up. Okay, does that make sense? Just like if you get, well, not that you'd hopefully get 2 out of 15 for a test, but you know, if you got 2 out of 15 for a test and your teacher said to you, oh, it's still on stat, that's why. Sorry, hang on, I'm just talking to myself here. You know, your mum said to you, well, what was your percentage for your maths test? You'd say 2 out of 15 times 100, wouldn't you? And then that would give you your answer as a percentage. Okay, so in this case here, it would be 13,33% of the days. No, it's not. It's not. So Naledi, they're not going to give you marks for calculating stuff that they haven't asked for. All right. So if they were asking you for the number of days which lay both above and below 1 standard deviation of the mean, then you would have to calculate that. But calculating the value that's 1 standard deviation below, they haven't asked for. Okay, so yeah, it would be futile. Okay, you're not going to get any marks for it, and you're just wasting your time writing stuff down. Okay, now let's have a look. No problem. Okay, so let's have a look at the next question. All right, they want us to calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean of the first 15 days. So how are we going to do that? That's now more of a thinking question. They want us to calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean of the first 15 days. Any ideas on how we should tackle that question? So if you go back to like grade 8, the way of answering a question like this. All right, let me just snip this question out and then we can work on it below. All right, grab that. Just give me 1 second. I'm just, here we go. I'll just do it over here. Okay, so I've taken this from upstairs. All right. If we're going to calculate the mean, doing it by traditional methods, right? So in other words, not using the calculator, how would we do it? What would I write? How would I calculate the mean? So now I'm asking you for the baby way to do it, like how you did it when you were in grade 8 or grade 9. Can you remember?
Ma'am?
Mm-hmm.
Do we add all the numbers and then we divide them? We divide it by the numbers that are in the sequence, ma'am.
Yeah, so we need to divide it by the number of numbers. Okay, so in this case, we're going to add 26, 13, 3, 18, 12, 34, 24. I'm just going to put them all here together, 24, 58, 16, 10, 15, 69. I'm running out of space now, sorry. 20, 17, 40. Okay, so all of that has got to be divided by how many pieces of data we've got, all right? So in this case, we've got 15 pieces of data. So if we added all those numbers together in the numerator and then had 15 in the denominator, we would work out that our average would be 25, right? So that's how a mean is calculated, by adding all of them together, dividing by how many we've got, and getting an answer. Now, if we go back up to the question here, they've said to us, they want us to, well, we'll worry about calculating the maximum now, but it says that Sam has to use, must use for the remainder of the month, if she wishes the overall mean of April to be 80% of the mean of the first 15 days. So how are we going to work out the mean of the first 15 days? What do we need to do there? We know what the mean of the first 15 days is. We want 80% of that. So how are we going to work that out? What are we going to find? Okay, so Cassandra, what I'm asking you here is that they want her, her overall mean of April to be 80% of the mean for the first 15 days. Okay, so that's over here. That's this bit of information here. So I'm asking you, how are we going to work out? Exactly, Ibrahim, exactly. All right, so we need to work out what is 80% of 25. Okay, so 80% of 25 is like taking 0,8 or 80 over 100 and multiplying it by 25. Okay, so 0.8 of 25 leaves us with how much? 20, right? There we go. All right, perfect. Okay, so that gives us 20. So now that is the overall mean for April that Sam wants. Okay, so she wants X bar to be 20. All right, so let's go back down and go and have a look at what we're doing over here. All right, so she wants this value over here . Oopsie, okay. She wants this value over here to be 20. All right. So what I'm going to do is I'm going to make X bar equal to 20. All right. Now I've got these first 15 days. All right. So in other words, I should have actually added these numbers together and worked out what they're equal to, but it really doesn't matter. Just get them all down again. Okay. Sorry, that's my divide line, which is very skew. How many days are there in April? How many days do we have in April? Okay, so a PWare, they told us that she wants her overall mean for April to be 80% of the mean of the first 15 days. So the mean of the first 15 days was 25, so 80% of 25. Okay, so here 80% of 25. That's where the 20 came from. Okay. All right, so how many days in April, Matrix? I mean, what I'm asking you essentially is what are we going to divide by? We're still going to divide by 15. Are there 15 days in April? No, there's 30 days, exactly. Okay, so that means that we need to divide this by 30. So that's the first 15 days. What are we going to call the remainder of the month? So the next 15 days. What do we call anything in maths when we don't know what its value is? Exactly. All right. So if we add the first 15 days to the next 15 days, and we want our average to be 20, we can then work out how much data she can use for the remainder of the month. We can take that answer. What does it want us to do? Oh no, it was the maximum amount. So we would add it. Here, calculate the maximum total amount of data that Sam has used for the remainder of the month if she wishes for the overall mean to be 80%. Okay, so this X represents the maximum amount of data that Sam can use for the rest of the month if she wants her average to be 20. Does that make sense to everybody? So in other words, now we need to solve for X. So we're going to cross multiply. So that's going to give us 600 is equal to, now what we need to do is add all of those numbers together. All right, and then we've got to take that away from 600. So here we're adding together 26 and 13 and all these other numbers, and then here we get down to what, 20 and then 17 and then 40. Okay, so when we add all of those numbers together, sure, I'm really struggling to see here in the dark, guys. Just give me a second. I'm just going to try and turn the phone with my battery on. Sorry, my phone for my lights, my cell phone. Okay, so if we add together all the red numbers, so 26, 13, 3, 18, 12. Sorry, I'm just doing this the long way so that you can see where the answer comes from. 34, 24, 58, 16, 10, 15, 69, 20, 17, and 40. Okay, I don't know about you guys, but I get 375. Okay, so 600 is equal to 375 plus X. So if we now subtract 375 from 600, then we get what you had said, Naledi, which was 225. Okay, so that is the maximum amount of data that she can use over the remaining 15 days of the month.